When was your last chemistry class? Yesterday? Decades ago? When it was doesn't really matter. I'll bet that your chemistry classrooms all have one thing in common: a giant periodic table on the wall. And I'll bet you've barely given it a second thought. But here's the secret: that familiar grid isn't some fundamental law of nature. It's a human invention, a filing system for reality itself. The information is universal, but the table? That's all us. And woven into its columns and rows are incredible human stories. Tales of love, regret, pride, and breathtaking exploration. These stories can inspire us, but they can also serve as warnings. The periodic table isn't just a tool for chemists, it's a tapestry of humanity's greatest achievements, and most cautionary tales. That's why I'm excited to introduce a new ongoing series. Welcome to Meet the Elements. Hello everyone, and welcome to the beginning of my new series, Meet the Elements. For this series, each video is going to focus on one of the known elements found on the periodic table. If you're worried that these videos are just going to be a bunch of trivia and facts about the different elements, fret not. While I am going to include some trivia about an element in each video, I want to focus on the stories around the elements. Stories about their discoveries, the people who discovered them, or circumstances that were influenced by a particular element. Consider this video episode 0, an introduction to the series and the periodic table of elements. After this, each video will focus on one of the elements found on the periodic table, starting with hydrogen and helium. But I want to know what element you would like to see next. Leave a comment on this video or any future episode of Meet the Elements, letting me know what it is you want to see. So without further ado, let's get started and meet the periodic table. The Greeks weren't lab rats, they were philosophy majors in sandals. Democritus guessed that if you kept slicing bread, you'd eventually hit an indivisible nugget, atomos. Not bad, but Aristotle preferred the 4-ingredient cookbook: earth, water, air, and fire. That selection dominated for 2,000 years while blacksmiths smelted, alchemists inhaled mercury fumes, and the scientific method was a far-off dream. Only a few elements show up pure enough to leave an impression: glittering gold, stinking sulfur, and illustrious iron, just to name a few. This rather tiny roster was the entire playlist until 1649, when an alchemist boiled 50 buckets of human urine and discovered phosphorus, a waxy solid that glowed a ghostly green and loved to burst into flames. The Pandora's box of elements cracked open, and by the 1860s, chemists had teased 63 elements from rocks, meteorites, and even the light of the sun. Every new find spoke its own language: new melting points, odd colors, random reactivity. Imagine walking into a library where every book's written in code and the titles are blank, and new volumes fall on your feet every week. What was needed was a way to keep track of it all. Johann Dobereiner stepped up first, spotting triads of elements, groups of 3 chemically similar elements, such as lithium, sodium, and potassium, that gained weight in tidy steps and all through tantrums in water. It was a neat trick, but it was hard to use for every element. Next up was John Newlands. He lined elements up by weight and noticed every 8th behaved like a cousin, calling this his law of octaves. However, this pattern died after calcium. Even so, the clues were starting to fall into place. Weight was important, chemical properties repeat. Something periodic was there. Someone just needed to keep shuffling the cards. Enter Dmitri Mendeleev. Facing a publisher's deadline, he allegedly turned his office into a massive game of solitaire, writing the elements on cards that he could move around until it fell into place. While the story of the cards is largely apocryphal, Mendeleev did create the first functional periodic table. His key insight? Keeping elements with similar chemical properties grouped together, going beyond the triads, and leaving blanks in his table where no known element fit. In these gaps, Mendeleev predicted the properties of the element that would fit there, using the surrounding elements as a guide. He labeled these gaps things like eka-silicon or eka-aluminum, using the Sanskrit prefix meaning one-like. Mendeleev bet these elements would arrive with specific weights, densities, and specific gravities. A few years later, a Frenchman isolated a new element from zinc ore, gallium, fitting right where Mendeleev put his eka-aluminum, but with one hiccup: the atomic weight didn't match. Mendeleev, confident that his prediction was accurate, told the French scientist to purify the sample some more, and lo and behold, Mendeleev was right the entire time. More of Mendeleev's predictions proved correct. Scandium pops into place where predicted, then germanium. Each new element clicked into place like a Lego brick. Finally, chemists had a way to keep the ever-growing list of elements organized. There were a few problems, though, namely the discovery of argon. It's heavier than potassium, but it doesn't behave like any of the surrounding elements. It was perplexing chemists where to put it. Was the periodic table dead in the water? Not at all. Chemists were just looking at the wrong number. Henry Moseley fired X-rays at elements and found a better way to ID them: atomic number. Argon, element number 18, slides in right before potassium, number 19, and the periodic table clicks tighter together. The discovery of atomic number made it easier than ever to place newly discovered elements, and it solved many of the problems Mendeleev still struggled with. Today, that grid of elements hangs in just about every chemistry classroom, but it's no wallflower. It is loaded with information. Need a pigment that won't fade? Scan the transition metals for multicolor ions. Want a semiconductor? Take a stroll down the metalloid staircase. Hunting for useful medical isotopes? Look below technetium where atoms ooze neutrons. The same grid that predicted gallium forecasts which elements cook inside red giant stars and which self-destruct by radioactivity. Your phone's lithium battery, the helium cooling MRI magnets, the indium tickling your touchscreen, all sit exactly where Mendeleev's law said they should well before engineers needed them. But the periodic table is also a diary. Read left to right and you follow the nuclear fusion recipe inside stars. Hydrogen to helium, helium to carbon, carbon to iron. But it's more than that. Each element hides stories about the scientists who discovered them, or how one element shaped the culture of villages and kingdoms. I'm hoping you'll join me as I explore the stories of humanity that lie in wait beneath each square of the periodic table. And don't forget to leave a comment suggesting the element you want to see me cover next. Thanks for watching.